So Unit 5, and we're going to do section 5.7. And we're going to go ahead and just do that within the same week with the rest of them because I've already taught you how to do section 5.7. It's really target 5.6. But I have already taught you how to do this when I've taught you how to do your other things. So this is solving differential equations. I've already taught it to you. So I will solve differential equations by separating the variables and integrating. We've already been doing that, so we're just going to throw this section in with all the rest. So like I said, this is target 5.6, even though it's section 5.7 in your book, and I'm just ahead of the game because I teach it to you early. So reviewing our vocabulary here, we get the general solution, that's the one with the plus C, and then we find the particular solution by substituting in our initial condition, which is information you're given, an ordered pair. You plug them in to find the value of C, which gives you a particular solution. And these are all solution curves to a differential equation. So we're going to move right into the first part of this, and I'll also do an example video of the integration part. But this first part is talking about just, are the following curves solutions to the given equation? All right, so to determine whether the given function, which is this function here, whether that function is a solution of this differential equation. Now, just like in Algebra 2 and Algebra 1 and Pre-Cal, if something is a solution of an equation, that means when you substitute it in, it should make the equation true. That's what it means to be a solution for an equation. You make the equation true. So what does this equation say? Y double prime, which means the second derivative, minus the function equals 0. So we've got to show that that is true. So we need our second derivative. Okay, so this is the function. So the first derivative is going to be cosine. And then the second derivative, we just take the derivative again. And the derivative of cosine is negative sine. All right, and so this is asking determine whether this equation is the solution to this curve. So I've got this differential equation. So y double prime minus y has to equal 0. So all I'm doing is plugging it in. So what was y double prime? Y double prime was negative sine minus what was function y? Well, that was sine. Does that equal 0 is the question. All right. If it equals 0, then that means it's a solution to this differential equation. If it does not equal 0, then that means it doesn't satisfy the equation. So that means it is not a solution. So here, if I do minus sine minus another sine, I get minus 2 sines, and that is definitely not equal to 0. All right, so this is not a solution. So determine whether the given function is a solution, and the answer is no. It is not a solution to this differential equation because the second derivative minus the function does not give me an answer of 0. All right, what about this one? Is y equals 4e to the negative x? Is that a solution of the differential equation? The differential equation is exactly the same. All I did was change and say, okay, is this function a solution? Okay, so let's do the second derivative, and then we're going to plug it into y double prime minus y has to equal 0. All right, so let's find the second derivative. So the first derivative, you keep your coefficient. The derivative of e to the negative x is e to the negative x, and then you have to multiply, chain on the derivative of your exponent, which is going to be negative 1. So this gives us negative 4 e to the negative x. All right, now I'm going to do the second derivative. Take the derivative again. Keep your negative 4. The derivative of e to the negative x is e to the negative x. And then we have to chain on the derivative of our exponent, which is negative 1. So in this case, negative 4 times negative 1 is going to be positive 4e to the negative x. All right, so now we're going to check, is this equation a solution to this differential? So let's see if plugging in the parts does actually give us 0. So we want y double prime. So y double prime was 4e to the negative x minus the function y, which was 4e to the negative x. Does that equal 0? Well, yes, because 4e to the negative x minus 4e to the negative x, they cancel. 0 equals 0. That is true. So in this case, yes, this equation does satisfy this differential equation here in the problem. All right, so that is a solution. So y equals 4e to the negative x is a solution of that differential equation. All right, what about this one? Determine whether the given function is a solution of the differential equation. This is still the same differential equation. So is this a solution? All right, so let's do the same thing. Y prime, keep your coefficient. The derivative of e to the x is e to the x. All right, y double prime, keep your coefficient. The derivative of e to the x is e to the x. So now I'm going to fill in this equation to see if I actually get a true statement. So my second derivative, which is c e to the x minus the original function, c e to the x, does that equal 0? And sure it does. C e to the x minus c e to the x is going to give me 0. So yes, that is true. So yes, this is also a solution to the differential equation. So the last one was, and this one was, but the first one was not. So all you do is just substitute it in and it has to satisfy the equation. All right. Number 4, for the differential equation, xy prime minus 3y has to equal 0. Verify that this equation, cx cubed, is a solution. So that's what I'm going to do first. All right, so in this equation, I need the y prime and I need y. So we just need the first derivative. So y is cx cubed. So y prime is going to be, multiply your exponent times your coefficient. So we'll do it that way. Multiply the power, so 3c, drop a degree, and then we don't have to change because it's just x. So the derivative is going to be multiply the power, drop a power down. So this is our first derivative. All right, so now we want to plug it into this equation, see if it's true. So x times y prime minus 3 times y, is that going to give us a 0 answer? So x times y prime is 3cx squared minus 3 times y, the equation y was cx cubed. Does that equal 0? So let's see here. This gives me 3cx cubed minus 3cx cubed equals 0. So of course, 3cx cubed minus 3cx cubed, 0 equals 0. So yes, so we have verified that that is a solution to that differential equation. Of course, it just said verify that it is a solution, so it should have been. So if it wasn't, we've done a math error somewhere. All right, now because it's a solution, find the particular solution determined by this initial condition. Y equals 2 when x is negative 3. So now I'm just going to take this differential equation. I'll change my color. I'm going to take y equals cx cubed, and I'm going to substitute in this initial condition. So y equals 2 when x is negative 3. All right. So that gives me 2 equals c times negative 27, because that's what negative 3 cubed is. So c is going to equal, when you divide, c is going to equal negative 2 27ths. So the equation is going to be negative 2 over 27. X cubed is the particular solution that satisfies the condition here that when x is negative 3, the answer is going to be 2. Okay? So this is the particular solution. This was the general solution, remember. The general solution always has your constant in it, and then your particular solution is when you substitute in a specific coordinate to solve for c, and that gives you the specific equation with that specific c value. All right? So I think we did all that one. Find the particular solution determined by the initial condition. All right. Okay, so that's all I'm going to do in this video. The rest of them are going to be finding general and particular solutions, doing separate and integrate. So make sure you watch the second video. Just make sure I don't do anything new.